Let us find all the asymptote to the curve x square minus y square whole thing square minus 2 into x square plus y square plus x minus 1 equal to 0. Given, we can write this equation as, let's write here, let's simplify it. A minus b whole thing square equal to a square minus 2ab plus b square. Next, we observe degree of term here. Degree of this term is 4. Degree of this term is 4. Degree of this term is also 4. Degree of I made a mistake, 2x squared. Degree of this term is 2. Degree of this term is 2. Degree of this is 1, and that is 0. Let's write, it's already in descending power, the terms. We find that all of them are degree 4. This is of degree 2. This is of degree 2. This is a degree 1, and constant is of degree 0. First of all, we'll equate the coefficient of highest degree power of x to 0. That cannot happen. X to the power, x to the power 4. Highest degree power of x is 4. Its coefficient is 1. 1 cannot be 0. Highest power of y is 4. Y to the power 4, its coefficient is also 1. That cannot be 0. Once again, we will look at the equation and see what is the highest power of x. Here is 1, 2. 2 is bigger than 1. And more than that, here is 2, and here we have 4. Highest power is 4. And look at the coefficient of highest power term, x to the power 4. That is just 1. That cannot be 0. Similarly, let's look at the powers of y. It's 2 here, and then it's 2 here, and 4. So highest power of y is 4. And the coefficient of term containing y to the power 4 is 1. That also cannot be 0. So we are forced to say no vertical asymptote no horizontal asymptote. What about oblique asymptote? For finding oblique asymptote, okay, so horizontal and vertical asymptote, pretty simple to say. What about oblique asymptote? For oblique asymptote, let's take x equal to 1, y equal to m. take x equal to 1, y equal to m. Now, once we do that, let's write phi 4m. Since degree is 4, we'll start with phi 4. Phi 3m, phi 2m, phi 1m. What is phi 4 of m here? Take x equal to 1 and y equal to 4, y equal to m for each of the term of degree 4. To each of term of degree 4. X equal to 1, y equal to m. X equal to 1, y equal to m, y equal to m. X equal to 1, so that's equal to m to the power 4 minus 2m square plus 1. Phi 3m, we will write x equal to 1 and y equal to m in each of term of degree 3. But do we have that? No. So we just write it equal to 0. Phi 2m, let's write x equal to 1 and y equal to m in each term of degree 2. What did I do? M equal to 1, y equal to m, x equal to 1. Rest of the quantity as it is. Oh, if I write bracket here, I should write plus here. Phi 1m, let's write x equal to 1 in each of the term of degree 1. There is only one term of degree 1. Next step, solve for phi 4m equal to 0. Next step, solve the equation phi 4m equal to 0. The phi 4m was the polynomial in n obtained by considering highest degree terms. These are all the terms with highest degree. This term is of degree 4, this term is of degree 4, this term is of degree 4. Solve the equation phi 4m equal to 0. that is m to the power 4 minus 2m square plus 1 equal to 0, or m square minus 1 whole square equal to 0, or m equal to plus 1 minus 1 plus 1 minus 1. It is of degree 4. It can have at most 4 roots and each of the roots are repeated. Next step. Here m will denote the slope and we will find equation of asymptote in the form y equal to mx plus c, where c denotes y-intercept. Next step. Determining c. Determining c comma y-intercept. Y-intercept of asymptote. Determining c comma y-intercept of asymptote. Okay, how shall we determine it? For that, we have formula. We have formula c into phi n prime m plus phi n prime phi n minus 1 m equal to 0 if phi n prime m is not equal to 0. But what if phi n prime m is not equal to 0? Then we have to use second formula, c square by factorial 2 phi n double prime m plus c by factorial 1 phi n minus 1 prime m plus phi n minus 2m equal to 0. That also if phi n double prime, and this formula is true if phi n double prime m is not equal to 0. But what happens if phi n prime m and phi n double prime m is both are non-zero? Then we will have third formula, c cube by factorial 3 phi n triple prime m plus c square by factorial 2 phi n minus 1 double prime m plus c by factorial 1 phi n minus 2 prime m plus phi n minus 3m equal to 0. Of course, again it depends on the criteria. If phi n triple prime m is not equal to 0. So while determining c, we will try with the first formula. If it fails, then we'll use the second formula, and if that fails, we'll use the third formula and we'll proceed accordingly. Let's do it. Here let's take we'll do case by case. M equal to 1 comma 1 minus 1 comma minus 1. Let's take first case, m equal to 1. Case 1, m equal to 1. Then highest degree of highest degree of the polynomial is 4. Highest power of degree of polynomial is 4. So n will be equal to 4. 4m equal to m square minus 1 whole square. This implies 541 is obviously 0. So first formula 541 is obviously 0. First formula fails. What about first formula is failing? Why? Because 54 dash 1 is 54m is this. This implies 54 dash m equal to 2 into m square minus 1 into 2m. Then 54 dash 1 equal to 2 into 1 square minus 1 into 2 into 1, that's 0, anyway 0. 54 dash 1 is 2 into 1 square minus 1 whole is 2 into 1 square minus 1 into 2 into 1, that is 0. Okay, so 54 dash 1 is 0. Next, so the first formula fails. What about 54 double dash 1? 54 double dash m. I think it's easier to differentiate the expression m to the power 4 minus 2m square plus 1 equal to, if you differentiate it, 4 into 3 into m square minus 2 into double derivative of m square is just 2. This implies 54 double dash of 1 is 12 minus 4, that is 8. That is not equal to 0. So we can solve for the constant here, solve for the y-intercept. Let's apply the formula. C square by factorial 2. 54 double dash of 1 is just 8. Plus C by factorial 1. 53 dash m. Where is 53 dash? That is 0. 53m itself is 0, so 53 dash m will be 0. Then 52m. 52m is minus of 2 plus 2 into m square, and value of m is 1. That got to be equal to 0. So that imply uh, 4c square minus 4 equal to 0, and so we can solve for c equal to plus minus 1. We have started with m equal to 1 and c equal to plus minus 1. Therefore, two oblique asymptotes are two oblique asymptote your value of y equal to mx plus c, y equal to mx, value of m is 1, value y equal to mx plus c, value of m is 1, and c equal to, in one case you got plus 1, and in another case you got y equal to mx plus c, value of m is 1, c is minus 1. So y equal to x plus 1, y equal to x minus 1. Those are the two oblique asymptotes corresponding to m equal to 1. What about m equal to minus 1? We'll do same thing. So let's do the case 2 now. Case 2, m equal to minus 1. Here also 5/4 of minus 1 equal to 0. 5/4 of minus 1 is equal to 0. First point, 5/4 of minus 1 equal to 0. Second point, 5/4 dash of minus 1 equal to 0, because 5/4m, let's recall 5/4m equal to m to the power 4 minus 2m square plus 1. If you differentiate it, you'll get 5/4 dash m equal to 4m cube minus 4m. If you take m equal to minus 1, then this will be minus 4 and it will be plus 1. So plus 4 minus 4 plus 4 will give you 0. What about 5/4 double dash minus 1? 5/4 double dash minus 1, that will be equal to, first of all we need 5/4 double dash m, that is equal to 12m square minus 4. 5/4 double dash minus 1 is 12 into minus 1 square minus 4, and that is 8, and that is not equal to 0. So again we'll apply second formula here. C, what is the second formula we have? C square by factorial 2 phi 4 double dash m plus C by factorial 1 phi 3 dash m plus phi 2 double dash m equal to 0. Sorry, phi 2m here. That is C square by 2 phi 4 double dash m evaluated at m equal to -1. That is just 8 plus C by factorial 1 phi 3m itself is 0, so we can just write it 0. Phi 2m, phi 2m is -2 minus 2m square, and we write m equal to -1, and so we have 4c square minus 4 equal to 0. That gives us c square equal to 1, and so c equal to plus minus 1. Therefore, asymptotes are y equal to mx plus c, m is your -1, mx plus c, c is plus -1, and your value of m is -1. And also earlier we have derived y equal to mx plus c, and c, there also we got -1, and there we have m equal to 1. Therefore, 4 asymptotes, it is of degree 4, so it will have at most 4 asymptotes are 4 asymptotes to given curve are y equal to x plus 1, y equal to x minus 1, y equal to minus x plus 1, y equal to minus x minus 1.